Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept of MAP guideline and how to implement MAP guideline in MATLAB Simulink environment. In the last tutorial, we have discussed different type of controller design, which could be possibly type A or type B. So the difference between the type A and type B is in type A, you will have the trigger layer, but in type B you will not have the trigger layer. So let's have a deep dive into all these layers and we will see like how these looks like. So as we already know, a controller design can have all the four layers, the top or root layer or level. This next is the trigger layer, and then the structure layer, and then the data layer. So coming to the top or root level layer, in this particular layer you will have a simple block, and inside this every design will be running or simulating. On the top level you will have the input and the output, and the description for the block should be there in the form of an annotation in the block. So in this model, the overview of the explanation of the model will be there in this annotation. The description of the functions, like all the functions that are being implemented in this particular diagram or inside this model, should be there at this particular level. Input and output description also should be there in this particular level. So what is these inputs are all about and what are the outputs that it is giving is the main important aspect which we should give in the particular annotation in the form of some description. So this is the top layer. So the top layer is done now. Now we will be moving to the trigger layer. In the trigger layer, we will be having multiple enable or triggered subsystem. So some of the subsystem could be like, for example, over here, if you look into the suspension system, it will have a execution of sample time, like it should have a sample time of 20 millisecond. But if you go to a safety system or airbag system, then in that case it should be very less, like in this example it is like 10 millisecond. So at this level you need to define all the inputs and outputs of your subsystem. So these are the components in which you need to define your input and output, and this also can give some priority into the block. So if it is a suspension system, then it will have a less priority compared to a safety system. So then you can give some priority to the blocks that you have. So based on that, it will be also triggered or prioritized, or the execution order also will be depending on such prioritization. So at this level, what you will be doing, like you need to have multiple trigger or enabled subsystem. That is the first point. Then in the description part, you need to like give what is the function is all about, and in the block name you can give also the priorities, like what are the priorities that it has, and how it should be implemented. And the function call, it could be either a, like there could be possibility that it could be either a edge trigger, or it could be a enable subsystem, or it could be a function call subsystem. But in this case all these systems should be atomic subsystem, so that it will behave as one unit, and based on that it will behave based on the simulation environment. So whatever the layer that we have covered is the second top layer. Now let's go to the next layer. So we have now covered the root layer and the trigger layer. Now let's jump into the structure layer. So in the structure layer, for example, if we have two systems that will be interacting. So in this case, both of the system will have the same sample time. And in this case, we will be like, for example, suppose this is a engine control system. So you will have a engine model, and you will have a transmission model. So both of them will be connected. The output of the engine will go into the transmission. It will give some output. So the entire model will be simulating at suppose for example 20 milliseconds. So whatever the output you will get from the engine control module, you will be getting in the transmission control module. So for this you need to have both the subsystems as an atomic subsystem, so that both of them will behave as one unit, and the execution order will be also designed accordingly. So that is how you can design the structure layer. So basically in structure layer you will be defining like how your system should be there at like at a little higher level, because after this layer you will be designing everything in the basic Simulink blocks. So let's jump into the next layer and we will see like how the layers are being organized for the next layer. So now we have covered the root level layer and the trigger layer and the structure layer. Now we will be coming to the data flow layer. So in this data flow layer, we will have multiple Simulink blocks. So these will be the basic Simulink blocks, and the Simulink blocks you already have seen, which is like a gain block or a constant block or some add blocks. So these blocks will be there present, and these will be the basic component of the design, which we already have seen in the previous Simulink tutorials also. So in this case, like suppose if you want to do the annotation, or you want to show like how the block are organized at this level, then what are the information that you should give in this level. All the descriptions should be given in an annotation part, so it will not have any impact when you do any code generation. So what you can give in that, you can give the function description, so you can show like what are the things that is operated or executed in this particular level of the design. Then you will be also able to define in the annotation that what are the inputs that are there and what is the significance of the input. Like if you are applying some force, then what is the unit of the force that is being applied, and suppose if you are getting some displacement as the output, which is suppose in meters, then for that also you can give some description in the output block, or for the output block in the annotation. So this is how all the layers are being defined in a control system design, or in a state flow control design. And as we already have seen, the total number of layers are 4. So first is the top or root layer, and then the trigger layer, and then the structure layer, and then the data flow layer. So data flow layer depends on how you are using the basic Simulink blocks. So here multiple layers are possible, and this is all related to designing of the controller. It is not designing of the plant model, and it also varies from organization to organization, so how they want to use. Some of the organization uses target link, some of the organization uses the basic customized blocks which they have created by themselves, and some of the organization use the basic default Simulink blocks. So how it is being organized, and what are the layers, like you can already, like you have already seen, like we can also avoid trigger layers in any design. So based on that, like whichever the design is needing which layer, so those layers will be taken into consideration, and then the model based design is developed. So this is all about the model architecture decomposition. In case you are liking the content, please share your thoughts and suggestions in the comment section. It will be a great help to us to improve the content in the channel. And yeah, please stay subscribed to the channel. Happy learning MATLAB. Have a great day. Thank you.